Hello guys, I hope your preparation is going on well and I am helping you in your preparation a little bit. So today we are going to start with the favorite topic, that is indefinite integration. Many students have a fear for this particular topic because mainly the reason is they have not understood the concept or they have not practiced enough this particular chapter. The importance of this particular chapter should not be emphasized more by me. You cannot fully ignore this particular chapter because it basically consists of three sections, that is there are three different chapters to it. You have the indefinite integration, then you have the definite integration, and thirdly you have the application of the definite integration. There is also application of your indefinite integration in case of solving of your differential equation. So basically this chapter overall will consist of 4 different chapters in your mathematics. So that is why the number of questions which will be coming from the section of integration itself will be quite large. You cannot even ignore this particular chapter because integration and derivatives forms the basis for your engineering studies. So that is why there is a lot of emphasis is given to this particular topic in calculus. If you are not confident about this chapter, I will try to make you a bit confident by just solving those set of questions which are often repeated in the examination, and how to solve them that in a much quicker and easy way. So let's go and see some problems in my indefinite integration. So let's look at the first question. This is my ratio of a polynomial. In this case it's a linear polynomial which is given to me, and I have to find what are the constants after solving, that is what are the constants a and b. So basically it's just you have to find what is going to be the integration and then look out for the terms of your coefficient of x and coefficient of log. So basically this term is going to come and then you can just simply find it. Now one way to solve this particular thing is solving actually the integration. Whenever you are having a polynomial divided by polynomial, what you try to do is you try to represent the denominator in the numerator. So that can be done in this way. You take the numerator equals some constant into the denominator plus some other constant. Then you find the coefficients of x and the constant term. So over here your coefficient of x will be 3. This thing will be equal to 5m. On this your coefficient of x is 5m. Next, considering the constant term, so you are going to get 4 on this side, and on this side it is going to be minus 7m plus n. So from this you are getting your value of m as 3 by 5. And you will be just substituting it in this, so you will be getting a 4 plus 21 by 5 is equal to n. So you will be getting your n value as 41 by 5. So now you will be replacing this with the substitution of m and n. So your m over here is 3 by 5 and n you are getting is 41 by 5. This thing is to be divided by 5x minus 7, 5x minus 7. So you are just splitting it up, and now you are finding the integration. So over here in the first term this gets cut, you are finding integration of this. So after integration, since it is 3 by 5 dx, so you will have a 3 by 5x. This one is my 41 by 5 divided by 5x minus 7 dx. So it's divided by a linear polynomial. Then in that case it is just simply going to be a log of that term divided by the coefficient of x. So in this case it's 5, so that will be divided by 5. So you will be getting a 41 by 25. So comparing your x coefficient and your log coefficient, your a is 3 by 5, b is 41 by 25. So your option is B. The other way for this particular sum which you can solve this sum is by just simply taking derivative of this part. So if you're taking derivative of that, because finding derivative is quite simple than finding an integration. So if you're taking derivative of this, you will be getting a where there is a ax, and you will be getting for this particular term a 5b by 5x minus 7, because log's derivative is 1 by 5x minus 7 and 5x minus 7's derivative is 5. So now it is just multiplying, cross multiplying. So you will be having a 5ax minus 7a plus 5b divided by 5x minus 7. So this term is present in the integration. You have to just compare this particular term. So comparing the x term, you are getting a 5a is equal to 3. So you will be getting a as 3 by 5. So just finding the a, because there is all the a terms are basically different over here, you can just take your b option when you get this particular. Moving to the next one, you are again having a polynomial divided by polynomial. So you will be representing your numerator as a m into the denominator plus n. But since it is quite simple, you can simply find out what it can be done. So what you will be able to do is you can write your x square minus 3 simply as x square plus 1, because you require the denominator term, and since you require the minus 3, you have to have a minus 4 over here. So you try to make this numerator in terms of denominator, that is the whole thing what you have to do. So now dividing this by x square plus 1, because you have replaced your x square minus 3 with this particular thing. So now splitting this up, it will be 1 minus 4 divided by x square plus 1. By now you should be able to identify what should be the answer, because it is going to be integral of this thing. So integral of 1 is x. So this option is wrong and this option is wrong. And then next is minus 4 by 1 plus x square. So 1 upon x square plus 1 is basically a tan inverse. So it's plus over here, so this should be a wrong answer. So your right answer is this. So you need not always find the whole integration. You can just, looking at the answer, you can just try to identify what should be the right answer. Moving on to the next one, you are again given your answer and you have to find the coefficient. So again you can apply the derivative over here. So derivative of this will be a 3x plus a plus b by x minus 1. If you are applying the derivatives in case of integration, you have to be very thorough with your derivatives, because if you are just taking more time in solving the derivative itself, then it's of no point to solve that integration problem. So now taking the LCM, you will be getting it as 3x square minus 3x plus ax minus a plus b divided by x minus 1. So your 3x is already present over there. Then comparing the x coefficient. So your x coefficient is over here a minus 3, which is going to be equal to 4. So you will be getting your a as 7. So just looking at the option, you can find it that a is 7 over here only. Otherwise it's not there. Moving on to the next one. In this case, you are having a polynomial into a multiplication of root of a polynomial. So in this case, what you have to do is you have to try to bring the polynomial which is present under the root outside. So you have to represent your x plus 1 in terms of 2x minus 1. So since you are going to represent x plus 1 in terms of 2x minus 1, this option is going to be wrong, because there are no terms in x plus 1 in the integration. So what you will be doing is you require your x plus 1 to be represented as 2x minus 1. So for that, if you are multiplying this by 2, so you have to divide by 2. So you will have a 2x plus 2. Now you require a minus 1, so you can write it as 1 by 2 of 2x minus 1 plus 3. So you will be having the terms as 2x minus 1 by 2 plus 3 by 2. So you're going to replace your x plus 1 in terms of this. So when you're replacing that, you have to just now multiply this. So you will be having this as raised to 3 by 2, because it is basically 2x minus 1 into root of 2x minus 1, which will be a 2x minus 1 raised to 3 by 2. Then plus 3 by 2 into 2x minus 1 raised to half. So now finding the integration of this. So this term will be 1 by 2, which is the constant outside, 2x minus 1 raised to 3 by 2. Integration will be 2x minus 1 raised to 5 by 2, because it is of the form x raised to n. So it will be 2x minus 1 raised to 5 by 2 divided by 5 by 2 and divided by the coefficient of x. Next, this term will be 3 by 2, which is the constant term. The integration of this is 2x minus 1 raised to 3 by 2, because it's plus 1 of that, divided by 3 by 2 and divided by the coefficient of x. So now this 2 gets cancelled. You will be having a 1 by 10 of 2x minus 1 raised to 5 by 2, plus the 3 gets cancelled and you are having a 1 by 2, 2x minus 1, 3 by 2. So your option basically is going to be your C. Moving on to the next type of problems, that is in my trigonometry. Now trigonometry forms another group of problems which are very important in your integration, because there are many types of trigonometric problems which can be asked in the exam. The sheer variety which the problems can be asked is too many. We will be trying to find what are the some types of integrations, or what should be done if some terms which are present in the integration are asked. So let us see the first one. They have given 4 integral of this particular thing. Now in this you are familiar with this term, that is sin 2x. Sin 2x has a value 2 sin x cos x. So let us try to manipulate that and let us find if it is going to help me in solving this integral. So just let me write the integral. So I will be having a sin cube x plus cos cube x divided by, I am replacing my sin 2x with 2 sin x cos x. So I will be having that's a square for that. So it's going to be a 4 sin square x cos square x. So you have the 4 outside, which basically cuts with this. So now what you will be doing is you will be splitting it up. So once you split it up, what you will be getting is a sin cube x divided by sin square x, which will give you a sin x divided by cos square x plus into dx, plus this second integral will be the cos cube x divided by cos square x will give you your cos x. So cos x divided by sin square x dx. Now in this, one of the cos, what you can do is you can combine with sin to make a tan. So you will be having a tan x, and 1 by cos over here, the remaining 1 by cos will become a sec x, plus same way the one of the sin will combine with cos to become cot. So you will be having integral of cot x, and 1 by sin will be cosec. So you should know that tan x into sec x basically is the integral for sec x, and this one is for minus cosec x. So just comparing, you will be getting the answer as this particular thing. The minus c is not of any importance, because the constant basically are arbitrary constants. They can be positive, negative. The value of that arbitrary constant is not defined yet, so that is why it can be taken as positive or negative. Moving to the next set of trigonometric problems, I am having this integral of sin square 6x minus cos square 6x. Many students have the tendency of making this as a x raised to n formula and then finding the integration of sine or cos. That's not applicable in case of integral. It is not like our derivatives in which we find the derivative of the outer and then the inner. In integration, there is nothing which is defined for composite functions. You have to make this complicated functions into the formulas, the list of formulas which you know basically. So you have to bring the square term into a single degree term and the cos square term also in the single cos or sine degree term. So let us try to apply what we know. So I know that sine square 6x, I can use the formula for cos 2x basically. That is a double angle formula for cos x. So my sine square 6x can be written as 1 minus cos of 12x by 2. And my cos square can be written as a cos 14x plus 1 by 2. So I have to find integration of these terms. So let us try to find. I will be having a 1 by 2 for this. So splitting up basically this. So I will be having 1 by 2 integral of this. Same way over here. 1 by 2 over here and 1 by 2 over here. So finding the integral. My integral of 1 by 2 will be x by 2 minus integral of cos 12 will be sine 12 x divided by 12 into 2, so that becomes a 24. Then this becomes integral of cos, which is again a sine 14x divided by 14 into 2, so that gives me a value of 28 and plus x by 2 and plus c. So this gets cut. So I am having a value which is given in the option A. Next, going to this particular problem, I am having a sine raised to 4 plus cos raised to 4. So again you have to bring the sine raised to 4 term into a single degree sine or cos. Same way, cos raised to 4 should be brought in the single degree sine or cos. Now in this particular problem, what you can try to do is you can just make it in this format. That is a sine square x plus cos square x the whole square, because if you just open this bracket you will be getting a sine raised to 4 plus 2 sine square cos square plus cos square square, which is cos raised to 4. So that middle term, that is 2 cos square sine square, will be cutting with this. So we'll be getting at this particular thing back. So you are representing this term as this two terms, because I know that sine square x plus cos square x is nothing but 1. So you will be having this thing as 1 minus 2 sine square x cos square x. Now what you can do is you have to find integral of this. So again you are having this square term over here. So you have to try to reduce it. So what you can do is, first of all, you can make this together part. Since you are combining the 2 also, which was just a 2, you have to divide by 2. Because if you just open the square bracket, this is going to be 4, but it was earlier 2. So that is why you have to replace or compensate via 2. So now this part becomes a 1 minus sine 2x the whole square by 2. So I know that how to replace a sine square x. So sine square x can be replaced by a cos. So 1 minus cos of 4x by 2. So now solving this particular thing. So you are having a 1 minus, this becomes a 1 by 4 of 1 minus cos 4x, and you have to find the integration of this. So 1 dx integration is x minus 1 by 4 integration of this 1 is going to be x minus integration of cos is going to be sine 4x by 4 plus c. So if you just open this, so it's going to be x minus x by 4 plus 1 by 16 sine raised to sine 4x plus c. So x minus x by 4 is nothing but 3x by 4, and this is plus 16 sine raised to sine 4x plus c. So now this particular thing, if you just check out, the option is going to be C. So these were some of the problems in my integration, that is indefinite integration. We will be seeing some more problems which are related to my trigonometry and some other types of problems which do come. I hope you have understood some of the solving parts or some of the tricks which can be used in this particular topic. If you have your own tips, you can share it in the comment section. Please go and watch the other videos which we have done on different topics. If you like this video, please hit the like button. Please subscribe to our page if you have not subscribed to it. Please hit the bell icon which is present besides the subscribe button, so that you will be able to get the notification as soon as we have uploaded a new video. In this whole month, we are going to do MHTCET mathematics videos. So please share, subscribe and like our videos and comment to us, so that it provides an inspiration for us also to do videos like this. So keep practicing, keep learning, keep watching, and happy learning. All the best. Bye guys.